In topic 10, we're going to be taking a look at rates, which is a special type of ratio. So, a rate is going to be a ratio that compares quantity with unlike units of measure. So, they're going to have different units of measure. Um, if we take a look at the very first problem on our solve and share, it says, what is the cost of 10 bottles of fruit juice? Solve this problem any way you choose. You'll notice that I have a ratio table here. So we're going to be looking at solving problems involving rate by writing rates, using ratio tables, and double line graphs. And so if we look at our rate is 4 for $10. So I'm comparing two different quantities. I'm comparing the cost of the bottles of fruit juice for how much it costs. So my rate is I'm looking of bottle or cost per bottle. And so I'm looking at what is the cost of 10 bottles of fruit juice. And so when I go ahead and I solve this, if I have 6 bottles of fruit juice, I have to look at what the cost is going to be. If I have $8 of fruit juice, I need to look at what the cost is going to be. And then if I have $10 or 10 bottles of fruit juice, what the cost is going to be. And so when I take a look at this one, what I can do is I'm going to start with the 8 because the 8 is going to allow me to double. And so when I double this, I end up with $20. So it's going to cost me $20. Now, this really value has not really helped me figure out how much it's going to be. So I'm actually going to change this 6 and I'm going to simplify my ratio or my rate. So here I doubled, here I multiplied by 2. I multiplied the bottles of fruit juice by 2. Well, here what I'm going to do is I'm actually going to divide the cost by 2. And so if I divide the cost by 2 and I simplify this out, this is going to be $5. And then 4 becomes 2. And so the cost of 2 bottles is going to be $5. And now from here, I can figure out the cost of 10 bottles because what I have is 8 bottles cost $20, 2 bottles cost $5, 2 plus 8 is 10. So 5 plus 20 is going to be 25. So 10 bottles of juice, I can buy 10 for $25. Notice that this rate language is also going to be different. I'm not doing 10 to 25 as my comparison. I'm doing 10 for $25. Okay, let's go ahead and take a look at the look back. It says Monica says that you can use number sense to find the cost of bottles of fruit juice. If 4 bottles cost $10, then 2 bottles cost $5 and 8 bottles cost $20. So 10 bottles cost 5 plus 20. Is Monica correct? Explain. So we did this. We talked about this as our ratio. And so she is correct because our initial, if we write it as a ratio language, it was 4 to 10. And then from there, I can create equivalent values to figure it out. So an equivalent ratio. So if I did um, 2 bottles for $5, so 2 bottles for $5, so I could evaluate it down, or my equivalent ratio would have been 8 bottles for $20. And then again, from there, I can use these two values to find the cost of $10. And so that's what we did. I just represented it a different way down here. All right, so let's move into your visual learning on the next page. The essential question for today is what is a rate? And we already talked about that it is a type of ratio that compares specific quantities. So if we take a look at this question, if the race car continues to travel at the same rate, how long will it take to travel 25 kilometers? Well, here's my rate. 10 kilometers in 3 minutes is my rate. So I'm going to write this with my unit of measurement. So notice here that I have two different quantities I'm comparing. I'm comparing kilometers to minutes. So when we have a rate, we need to make sure that we include our language or include our units of measurement. So I can do this a couple ways. I can create a ratio table. And so if we look at our ratio table, if I have 5, so we started with 10 to 3. If I back my distance to 5, I divide my time in half. If I go up by 5, I add a minute and a half. If I go up by another 5, I add a minute and a half. and then I keep going up by 5. Every 5 minutes is going to be a minute and a half. So I end up with 7.5 minutes to travel 25 kilometers. The other way that I can do that is I can write the rate as a fraction, and then from there, we can create an equivalent fraction. And so if I have 10 kilometers equals 3 minutes, or 10 kilometers, for every 10 kilometers I travel, it takes me 3 minutes. What I need to know is, hey, here I have 25 kilometers, and here I have X minutes. And so I'm looking at what value do I multiply 20, or do I multiply 10 by to get to 25? And so if we look here, we multiply it by 2.5. And so if I multiply 10 by 2.5, I get 25. 3 times 2.5, I end up with 7.5 minutes. So that is my rate. So it is going to be 25 kilometers in 7.5 minutes. All right, so if we take a look at the convince me, Sal draws the double number line diagram at the right. He says that it shows that at this rate, the race car will travel 35 kilometers in 10.5 minutes. Critique Sal's reasoning. Is he correct? Explain. So let's take a look at what he drew and then critique the reasoning if we need to. So we start at 0 kilometers, 0 minutes. Okay. Then when he travels 10 minutes, or 10 kilometers, it's 3 minutes. 20 kilometers is 6 minutes. 30 kilometers is 9 minutes. 40 kilometers is 12 minutes. And then in between here, I have a minute and a half. Okay. And so we know that we go back up to where I have the lowest value that I have. So I have 5 and 1.5. So for every 5 kilometers I travel, it takes me, so 5 kilometers, it takes me 1.5 minutes. And so what I'm going to do is, if I need that and I'm going to 35 kilometers, I want to know how many minutes is it going to take me. Well, what I need to do is here I multiply this by 7, and we know that when we talk in fraction world, whatever I do to the numerator or denominator, I have to do to the other part to keep it balanced. So I need to take 7 and multiply that by 1.5. And when I take 7 and I multiply that by 1.5, I end up with 10.5 minutes. So Sal is going to be correct. So he is correct because this right here, the kilometers, this corresponds to how many kilometers he travels. This corresponds to how many minutes. When we solve it, we end up with 10.5 minutes. All right, so let's go ahead and move on to our guided practice. It says use what you know about ratios to explain how a rate is different than a fraction. So a fraction, when we talk about a fraction is comparing, let's go, I don't like to do green because I have green. Let's go pink. A fraction compares a part to a whole. So fraction compares part to whole. A rate compares different quantities. So I'm comparing minutes to miles traveled. I'm comparing miles per gallon. I'm going to be comparing miles to hours. So I'm comparing different things. Cost per pound. Those are all different things that I am going to be comparing when I compare a rate. Okay, so that's the big difference. A fraction is a part to whole. A rate is comparing different quantities. So it's not going to be the same thing as a fraction. All right, if we take a look at number 2, a semi-truck uses 40 gallons of diesel fuel to travel 320 miles. Steve says this ratio can be written as 2 different rates, 40 gallons to 320 miles, or 320 miles to 40 gallons. Do you agree? Explain. So if we look at these, are these going to be good rates to use? And so we just have to look at what they represent. Here I have my gallons on top, miles on the bottom. Here I have miles on top, gallons to the bottom. Both of those are going to work because it's 40 gallons of fuel to travel 320 miles. These work as rates, okay? So both are correct because they both compare miles to gallons. Even though they're flipped around, they both compare miles to gallons, so I can write that ratio as two different rates, but the comparison stays the same. Okay. Number 3, Jenny packed 108 eggs in 9 cartons. Write this statement as a rate. So we're going to write it as 108 eggs. And notice that with my rates, what I'm doing is I'm writing my rates in the fraction form. So it's 108 eggs for 9 cartons. If I write this as a rate in written form, it would be 108 eggs per 9 cartons. So it's a little bit different than a ratio, because a ratio would be 2. Here it's going to be per, not cartoons, cartons. Cross out one of those N's or O's, per 9 cartons. All right. So in 4 and 5, we're going to find the value of N. And so when we look at the value of N, what we're going to do is here I have 45 to, I'm going to write it as a rate, 135. So if I'm writing it as a rate, I need to include my units of measurement. So miles per hour. Actually, I'm going to write this on the other side so I have more room to write. So it's 45 miles per for every 4 hours. And I want to know if I have 135 miles, how many hours is that going to be? And so to find that, I'm going to do 135 and I'm going to divide that by 45. And my guess is that it's going to go into 45 is going to go into 135 3 times, just because 45 or 4 times 5 is going to be, 4 times 3 is going to be 12. So 5 times 3 is going to be 15. I put down the 5, regroup the 1. 3 times 4 is going to be 12, plus 1 is going to be 13. So I was correct. So my rate is going to be 135 miles for every 3 hours. Okay, so next one that I'm going to do is I'm going to do cost per pound. And so when I look at cost per pound, I start with my zeros. For 1 pound, it costs $2. For N pound, it costs $5. So if I have a 1 pound, there's my unit of measurement because it's a rate, to $2, I have to look at how do I get to $5 with I have N. And so 2 times what's going to get me to 5. And so here I'm actually going to multiply this by 2.5. And so when I multiply that by 2.5, that means I have to multiply this value up here by 2.5. And so my new rate is going to be, or N is going to be equal to 2.5 pounds for every $5. So just make sure I include my unit of measurement. Okay. So for your independent practice, what I'd like for you to do is you are going to do all of 6 through 9. And actually, so you're going to do 6 through 9. I would like for you to do 10, 11. Actually, I'm looking at it. I'd like for you to do all. So you're going to do your entire practice today. So you are going to do 6 through 14 for your independent practice.